Hey guys, so let's review dilations. Remember that dilations are the only type of transformation where our graph actually changes its size. So here's my original f of x in black, and what you notice is that the red one and the purple one look like they're a different shape almost. They're both kind of that V shape, but this one is shorter than the original, meaning it's kind of been squashed down, and the red one looks like it's been elongated. It's been stretched upwards. So this red graph, the R of X graph, is actually considered a vertical stretch in comparison to the black graph. The purple one is considered a vertical shrink because even though it looks a little bit wider, it's definitely shorter. When I look at my endpoints, I can see that more clearly. So here I have 5 comma 2, meaning when I put in 5, I only get out 2 for this black graph. What about on the red graph? At 5, I get out 6. So how do I get from 2 to 6? Well, clearly that y value has grown by a multiple of 3. And whenever we're talking about these stretches, it's always going to be multiplication, not addition or subtraction. That is reserved for a shift left, right, up, or down. There's no shifting happening here, just a stretch. So how can I show to get from 2 to 6? Times 3. So what I'm going to write here is 3 times f of x. And notice how I didn't put a multiplication sign here. You can if you want to, but it's unnecessary. It gets the same equation either way. So again, how did I figure out 3 there? Make sure you're starting at the black f of x graph. I think that's the problem most people are having. They don't know where to start. If the problem reads, write the equation for r of x in terms of f of x, well, that means that I should start at f of x and figure out how do I get from there to red, to r of x. So whatever's second in the statement should be your starting point. I'm starting at black, and here I look at my y value. I go from 2 to 6. That means I multiplied by 3. So again, 3 times f of x. What about if I want to go to p of x from f of x? So in other words, the problem might say, write the equation for p of x in terms of f of x. Again, I'm starting at f. I'm starting at the black function. And then I need to get to the purple. So I've got to think to myself, how can I get from 2 as my y value to 1 as my y value? How can I get from 2 to 1? Well, if I'm going to multiply, that means I'm going to have to multiply by something smaller than 1. In fact, how do I get from 2 to 1? I'm cutting in half. So what I'm going to write here as my equation is 1/2 times f of x. And that lines up with my purple. Some people might also say, well, I'm dividing, right? Dividing by 2. You can write it that way too, but we prefer to show it through multiplication. So really, you're going to see us type it out as 0.5 f of x or 1/2 f of x. That's up to you. So what about this last guy here, this blue one? Let's call him b of x, right? How do we get there? Well, let's look at our original function. Does it look like any type of stretch or shrink has occurred to create this graph? No. Honestly, to me, it looks like this graph has just been shifted down 4 units. And so that's all that's happened here. If I want to shift, I've got to show that through addition or subtraction. So here I'm going to subtract by, let's count it out, 1, 2, 3 units. Okay, so notice the difference between these two equations. Here I shifted down 3, I have to subtract. Here I multiplied by 3, and that created this stretched out graph. Hopefully that helps to clear this up.